Okay, class. In this lesson, we're going to talk about how to factor polynomials, and specifically, I'm talking about three-term polynomials. Okay, and I'll define what that is. So in this lesson, I'm going to show you how to do it, and I'm going to explain why this is important. Okay, so here is an example of a three-term polynomial. Okay, these are three different monomials. Okay, so this is a monomial, this is another monomial, this is another monomial. And when I say monomial, I'm talking about monomial. Okay, mono being one. Okay, so there are three of those, so three monomials. Okay, there are different types of polynomials that you will need to learn to factor if you haven't already learned them. What I'm going to show you is one specific type. In this case, this is a three-term polynomial. So when you look at this particular polynomial, you're going to want to make sure that there's nothing else that you can factor out. Okay, this is going to be another lesson if you haven't already learned this, but you're going to try to make sure that this particular polynomial doesn't have any common factors that can be factored out. And in this case, it doesn't. Okay, so the assumption here in this particular lesson is that it can't. There are no other factors that can be factored out. Okay, so in this particular scenario, or in this type of problem, we're going to set this problem with two sets of parentheses. Okay, now in each one of these, because we've got an x squared here, we're going to just draw or write in an x here and an x here. Okay, now this is the hard part in factoring this particular polynomial. For this problem, it's fairly straightforward, but in other types of problems, this is the hardest part. Okay, and what you want to do is take a look at this third term. Okay, in this case, it's 2. And what you want to identify are all of the different factors that make out 2. Okay, so I'm going to just point this over here. Point this over here. And I'm going to write the number 2. I'm going to put an underline underneath. This is just my way of doing it. You don't have to do it this way, but visually it helps to see what's going on. So the factors of 2 are 1 and 2, okay, and -1 and -2. Okay, we're kind of in advanced algebra now, so we're going to have to think of all the different variations of integers that are factors of the number 2. Okay, so we have to take into account positive and negative values. Hopefully by now you know that a negative times a negative will yield a positive. This is why we have a pair of -1 and -2. Okay, so what we're doing here is we're saying, does 1 times 2 equal 2? And does 1 plus 2 equal 3? Okay, so and then in the next set, it isn't necessarily to do this, but I wanted to go through this so that you can see what's going on. So 1 times -2 is equal to 2, okay, and then 1 plus -2 gives me -3, okay. So what we want to look at is which of these sets here give us the values that we're looking for. Well, what do I mean by that? So I'm going to go back to this polynomial, and I'm going to just recolor this number 3. Okay? All right, so now what we're doing here is taking a look at this set right here. Okay, the factors of 2, 1 and 2. We know that 1 times 2 is equal to 2. Okay, that satisfies this 2, and then the 1 plus 2 gives me 3, and that satisfies the second term in the polynomial. Okay, when you find a set of factors, sorry about that. When you find a set of factors that satisfy both the second term and the third term, then we know which elements go in here. Okay, so in this case, we're going to have +1 and +2. Okay, where did the +1 and +2 come from? This is my +1 and this is my +2 over here. Okay, so that's essentially how you factor. That might have been a little confusing, so let's try another example, and hopefully the second time around it'll make a little more sense. Okay, so here's another example of a polynomial that we want to factor. X squared minus 1x, actually. Let me rewrite this. Okay, x squared minus x minus 20. Okay, now I've made the x, the negative x, a color green, and then the 20 in red to hopefully help you see what's going on a little bit better. Okay, so assuming that there are no other factors that could be factored out, and this is about as far as you can go in terms of factoring, we're going to do this. We're going to always put two sets of parentheses. Okay, and we know that this is x squared here, so it's going to be split into two different x's. So we know this is going to be x, and then this is going to be x. Okay, so now I'm going to move this 20 over here. Okay, it's actually a negative 20. Okay, you got to remember, take a look at the sign here. The sign in front of the number is always important. So if it's a positive 20, we're going to write 20 over here. If it's a negative 20, we're going to write negative 20. Okay, so now we're going to find out or figure out what are the factors of negative 20. Well, let's start with 1 and negative 20, negative 1 and 20, 2 and negative 10, negative 2, positive 10, 4 and negative 5, and negative 4 and positive 5. Okay, so we know that these are all factors of negative 20. Okay, so this portion is already satisfied. Or we know that some combination of these pairs will, when multiplied together, will give us negative 20. Okay, so now the trick is to figure out what pair, when added or subtracted together, will give us a negative x. Okay, well, let's take a look. Let's take a look at this first set. Is 1 plus 20, 1 plus negative 20, what is that equal to? That's negative 19. Okay, so that's not what we want. What about negative 1 plus 20? Okay, that gives me 19. Okay, that's not what we want either. Well, and how do we know that that's not what we want? Okay, we're looking for something that when it's added together, added or subtracted together, it's going to be a negative x. Okay, this is not a negative x, or negative 1x, sorry. The coefficient in front of the x here is negative 1, so we're looking for a negative 1. Okay, all right, so let's keep going. 2 plus negative 10 is equal to negative 8. Okay, still not what we want, but we're getting closer. Negative 2 plus 10 is 8, so that's not what we want. 4 plus negative 5 gives me a negative 1, and that's what we're looking for. Okay, and let's just check the last one. Negative 4 plus 5 gives me a positive 1, so that's not what we want. So now we know that this is our pair. Okay, we know that this is our pair again because 4 plus negative 5, okay, this is when we're adding or subtracting together, gives us this negative 1 coefficient, which is what we're looking for here. What's implied here is a negative 1. Okay, so when that happens, we're going to take this positive 4 here, and we're going to put that in here. It doesn't matter which one. You could put it here, or you could put it here. The key is that this is a positive 4, and the other one's a negative 5. So here, this is what we're going to write. Positive 4, negative 5. All right, so those are just two basic examples. There are other variations which I will not cover in this lesson, but I do want to explain why this is important. Okay, in math, everything that you learn is built upon the previous concept or technique you learn, and it's all designed and built to help you solve the next thing. Okay, what's going to come up is you're going to learn to solve for y-intercepts, or when you're graphing functions, you're going to want to know where the graph crosses the x-axis. Okay, And when it crosses the x-axis, what you will learn is that the y value, okay, the y coordinate will be equal to 0. So going back to that previous example, x squared minus x minus 20, okay, if we set that equal to 0, and it's going to be 0 because this is a function that's going to cross the x-axis, we need to figure out where on the x-axis does that function cross. Okay? So, if we take a look at this particular polynomial, solving for x is difficult. You can't, you're going to have trouble figuring this out. Okay? But if you know how to factor, okay? So in like the previous example, we said that it was going to be x plus 4 times x minus 5 is equal to 0. Okay, you don't need to know how to do this, but I'm just showing you the value and understanding why it's important to learn to factor. So when you know how to factor, we can now set it equal to 0, okay? And then once you set it equal to 0, the product equal to 0, we'll now know that this is going to be equal to 0 or x minus 5 is equal to 0, okay? I'm not going to explain why this is happening, but I'm just showing you the technique. And then as later on in a lesson that I'm going to show you that helps you to identify where the x-intercepts are. Sorry. Then I will explain the why behind the scenes here. Okay. But in any case, being able to factor helps you to find the y-intercepts on the x-axis. So here we're going to have x is equal to -4 or x is equal to 5. So we know that this function crosses the x-axis at -4, 0. I'm going to just write or and. In this case, it'd be 5, 0. Okay. So if you think about the x-axis, okay, 1, 2, 3, 4, 5, 1, 2, 3, 4. This function, okay, it's going to look, it's going to be a parabola, but in any case, it's going to cross the x-axis here and at 5. Okay. All right. So again, you're going to need to learn to factor so that you can solve for the intercepts. And if you don't know how to factor, solving for this and figuring out where the intercepts are will be very, very difficult. Okay, so hopefully that's enough of a motivation, maybe a tiny one, to help you to master the factoring. Because once you know how to factor, then you're now going to put another tool in your tool belt that you're going to need to be able to solve other things later in math. Okay, so that's the end of our lesson. If you have any questions, if you're not sure, feel free to add your question to the comments, or just go back to the recording and review the video again. Thank you.